Hello students, hope you are doing good. Today we are going to discuss the important concepts of an important subject in civil engineering point stream, which is hydrology and irrigation engineering. This subject is equally important in competitive examination point of view as well as practical application point of view, like in rainfall calculation, how is this rainfall useful, etc., and how is this rainwater which is useful for irrigation engineering, etc. So in this video we are going to discuss the insights of this subject. That means what we have in this subject, what are the topics in this subject, and what we have exactly in the various topics. That means what we need to learn with respect to GATE, ESC, PSU examinations point of view. So apart from these things, in this video I am also going to discuss about the various types, new kind of problems and frequently repeated kind of problems which are repeated in GATE, ESC and PSU examinations, as well as few tips and tricks that are going to help you out in this subject in order to make the problem solved easily, and you can save some equal amount of time as well. So starting this video, we have various topics. What we have first, this subject total, hydrology and irrigation, we can comprise into two parts, or else we can classify into two parts, which is hydrology, the first part, as well as irrigation being the second part. Now, with respect to GATE exam point of view, I want to tell you the total weightage of this subject ranges from 7 to 8 marks. Okay, that means 7 to 8% of the total marks weightage in civil engineering stream in GATE examination paper. Now, out of this 7 to 8 marks, how we can classify this subject is, out of the hydrology portion itself, you can expect a weightage of, an average weightage of 5 to 6 marks from hydrology, as well as an average weightage of 1 to 2 marks from irrigation engineering. Now, let's start with hydrology. Here are the topics what we have in hydrology. So, what do you mean by hydrology? Hydrology means the study of occurrence, distribution, as well as movement of water. Here itself, hydro. In hydrology word, hydro means water, ology means the study. So, hydrology means the study of occurrence, movement and distribution of the total water resources in our world or else in our country, whatever we have. Okay, so in this hydrology, as we discussed, it deals with water. How we have the water? That means what is the source we have the water? The major source of water is rainfall. Okay, that means once we have the rainfall, that means we need to call it precipitation technically, because rainfall is a type of precipitation. That means we can call it as form of a precipitation. Now, how is this? What are the various types of precipitations? In this first topic, precipitation, what we have, we will be studying about various types of precipitations, that is convective precipitation, cyclonic precipitation, as well as orographic precipitation, as well as frontal precipitation. These are the four types of precipitations which occurs due to the different causes, which occurs in different seasons at different places. And as well as what are the forms of precipitation? Forms of precipitation means, is the precipitation a rainfall? Is the precipitation, that means, is it a light rain? Is it a moderate rain? Is it a high rainfall or large intensity rainfall? That means we can divide this on the basis of intensities. If the rainfall is of low intensity, we call it light rain. If the rainfall is of moderate intensity, we call it moderate rain. If the rainfall is of high intensity, we call it high rainfall or heavy rainfall. Next, the other form of precipitation other than rainfall is snowfall, drizzle, fog, mist, etc., hail, etc. So all these forms are all these are the forms of precipitation. Now, most of the people, they call rainfall itself as precipitation or precipitation itself as rainfall. That means rainfall is a form of precipitation, but rainfall gives a significant amount of water when compared to all the other forms of precipitation like snow, fog, mist, dew, etc. Therefore, most of the people, they call precipitation as rainfall. In the subject also, we will be terming it as rainfall as precipitation, precipitation as rainfall. Now, once we call the precipitation as rainfall because it's an important source of water, precipitation can be called as rainfall. So, in this topic, so-called precipitation, we need to study about what are the various types of precipitation, forms of precipitation, most important form of the precipitation being rainfall. And now, the next important point in this topic is how to measure the rainfall. We know rainfall is measured by an instrument so-called rain gauges. And we have various types of rain gauges like recording type of rain gauge, non-recording type of rain gauge. Recording type of rain gauge means it gives you the data of rainfall as well as it records the data of the rainfall which can be used for future purpose. Whereas a non-recording rainfall is not going to store any data. It can be used for instant purpose. So these are the two important forms of rain gauges which are used to measure the rainfall, namely recording rain gauges, non-recording rain gauges. Next, for suppose if we take an area, that means any city or else any place or else any town, that means an area where there is rainfall occurring, we can call it as catchment area. So in the catchment area, we need to study in this topic how many number of rain gauges we need to have. That means which we call it as optimum number of rain gauges. This kind of question can be expected in GATE exam. We have the formula for optimum number of rain gauges. N is equal to CV by E whole square, where CV is the coefficient of variation, E is the percentage error we can allow. That means more than this E, we cannot allow more number of percentage of error. That means here you can see N is inversely related to the error. That means when you have more number of rain gauges in a catchment area, the error will be lesser. When you have less number of rain gauges in a catchment area, the error will be more. So on this formula, you have the chance of questions in GATE exam, which is a very important thing, very important kind of question. Next, after this, we have the calculation of missing rainfall. That means, let's assume there are some 4 or 5. Let's assume some 5 number of rain gauges in a catchment area, out of which, let's assume we know the average rainfall, but I am assuming some rain gauge stopped working. That means out of these 5 rain gauges, let's take some 5 rain gauges A, B, C, D and E. I am assuming some rain gauge stopped working. Then how to compute the data? We can compute the data by 2 ways. First is the average method. That means if you know the average value, you can take all the 5 as the arithmetic average so that you can get the answer. The other method what we have, which is an important method with respect to GATE exam point of view, which we call it as normal ratio method. How to solve this normal ratio method? Now, how to solve this normal ratio method? We have a formula for this normal ratio method, that is Px by Nx is equal to 1 by m into P1 by N1 plus P2 by N2 plus so on Pn by Nn. That means I am assuming there are some n rain gauges in a catchment area, out of which one rain gauge is not working. That means we cannot have the data of that missed rain gauge station. I am assuming some Px. That means there is a rain gauge station X which stopped working, for which we need to find out the precipitation value. And now P1, P2, so on Pn are the precipitation values recorded by various rain gauges. Whereas N1, N2, N3, Nx, so on Nn are the normal annual precipitation values recorded by those rain gauge stations in an year. Normal annual rain gauge precipitation values I am repeating. So these are the annual precipitation values P refers to, and refers to the normal annual precipitation values. So this method is appropriate method in order to calculate the missing rainfall data values. And this is an important kind of question you can expect in GATE as well as ESE examinations in the last 10 years. Next, the other topic what we have in precipitation is the presentation of the precipitation values. That means how to present. That means how do you present the data what you have from the precipitation. Now, first type is you can take on a graph sheet. That means on the y-axis you can take the total rainfall, on the x-axis you can take the time, which we call it as mass curve. So a mass curve is going to represent rainfall versus time. And the next form of precipitation is hydrograph, which is a very important thing. I'm repeating again, hydrograph is very important thing throughout the hydrology engineering. Now, what do we have in hydrograph? A hydrograph is nothing but a plot of rainfall intensity versus time. That means rainfall intensity is taken on y-axis, whereas time is taken on x-axis. Now, I want to tell you that rainfall is measured in centimeters, whereas rainfall intensity is measured in centimeter per hour. That means rainfall intensity means amount of rainfall that is falling in centimeter with respect to unit time. Therefore, rainfall is measured as P, whereas rainfall intensity is measured as P by T. I is the rainfall intensity, which we can call it as P by T. This is an important thing without which we can't solve most of the problems in GATE in hydrology. Therefore, the units of rainfall intensity is centimeter per hour. And the next kind of presentation of this rainfall is DAD curve. We call it as DAD curve. That means depth, area, duration on a single plot. The other form what we have is IDF curve. IDF curve stands for intensity, duration and frequency curve. We have one more form for the presentation of the rainfall data, that is DDF curve. DDF curve stands for depth, duration and frequency curve analysis. All we have on a single plot. So these are the topics we expected to study in precipitation, and the most important kind of questions we can expect on precipitation is how do you measure the rainfall? How do you calculate, that means how many number of rain gauges you require, that means optimum number of rain gauges, as well as if you have any rain gauge not working, then you need to work out the missing rainfall data, that means estimation of missing rainfall data by using normal ratio method, as well as how do you present the rainfall data, that means are you presenting by using mass curve, or else are you presenting by using hyetograph, or else by using DAD curve, or else by using IDF curve, or else by using DDF curves. So this we have in the first topic, so-called precipitation. Next you have the second topic, so-called mean precipitation calculation. What do you mean by mean? Mean means average. So whenever you have more number of precipitation values, that means when you have some 4 rain gauges, that means 4 rain gauges are going to give you 4 different rainfall values. How do you get the average rainfall value? Which we have 3 methods in this topic. So the 3 methods what we have in mean precipitation calculation are, first one is average precipitation method. That means whenever you have some 4 values or 5 values, do the average directly. That means P bar is equal to, I am assuming you have some 4 rain gauges and each one is measuring some rainfall values, P1, P2, P3, P4. Now the average value is P1 plus P2 plus P3 plus P4 by 4. This we call it as arithmetic average method or arithmetic mean method, in which we directly take the simple mean or the arithmetic mean. The second method what we have is Thiessen-Polygon method. In this Thiessen-Polygon method, we do consider the total area, that means we do divide the total area with respect to each area covered by each rain gauge network. Now, the most important step in this Thiessen-Polygon method is how to work out the area that is covered by each rain gauge. So, Thiessen-Polygon method, we call it as Thiessen-Polygon method. That gives you the average rainfall value by using the formula P bar is equal to P1 A1 plus P2 A2 plus so on Pn An divided by A1 plus A2 plus so on An. That means first P1 is the rainfall recorded by the rain gauge station 1 and A1 is the area that is influenced. That means the area for which the rain gauge is recording the first rainfall value. Area influenced by first rain gauge. P2, rainfall recorded by rain gauge station 2. A2, area influenced by second rain gauge. So the most important thing in GATE exam is how to work out the area influenced by each rain gauge station. So it depends on the shape, whether it's a square, whether it's a rectangle, whether it's a triangle, whether it's an equilateral triangle, or else sometimes you can assume the catchment to be in the shape of a circle. Sometimes you can assume the catchment to be in the shape of a sphere. So during the calculation of these formulas, you need to be well versed with the area of equilateral triangle, area of square, area of circle, how do you divide the areas. All these things are very important. So I want to tell you, Thiessen-Polygon method is very, very important in GATE exam point of view. On an average, in the last 10 years data, you can expect this Thiessen-Polygon method at least once in 2 to 3 years. So once after the Thiessen-Polygon method, the next method what you have in the calculation of mean precipitation is your isoheightal method. What do you mean by isoheight? Isoheight means a line joining points of equal rainfall values. Okay. So isoheight means a line joining points of equal rainfall values. Apart from isoheight, iso means same or equal. Apart from isoheight, we have one other thing, so called isonif. ISO-NIF. ISO-NIF I'm repeating. So ISO-NIF stands for the line joining points of equal snowfall data. So you need to remember the line joining points of equal rainfall data is known as ISO height, and the line joining points of equal snowfall data is known as ISO-NIF. And how to work out the problems by using isoheightal method we need to see.